All right, let's get right into it. Today we're talking about one of my absolute favorite tools in the C++ toolbox, the STD map. And the best way to think about it? It's like your own personal, super fast dictionary, but built for your code. So you're used to things like arrays and vectors, right? You need some data, you just grab it using an index, 0, 1, 2. Easy. But what if the thing you're looking for isn't a number? What if you need to look up a user by their username, or find a product's price using a weird, clunky products code? That's where your standard array just kind of falls flat.
And this slide just lays it out perfectly. A vector, it's stuck in its ways. You can only use those integer keys, 0, 1, 2. But a map? Oh, a map is a whole different beast. You can use almost anything as a key. A string, a custom ID, you name it. That freedom, that flexibility is what makes it a total game changer.
So let's properly introduce the solution to our little problem here. We're going to really dig into what a map is, and you'll see why that dictionary analogy is just so perfect. Okay, here's the textbook definition. Now, don't let the fancy words like associative container throw you off. All that really means is that it associates one thing, a key, with another thing, a value. It just creates a direct link, a connection between two pieces of data. At its core, this is all it does. It's that simple. You give it a key, like the word 1, and it points you directly to its value, like the word uno. It's exactly like flipping open a dictionary to find a definition. Simple, right? But incredibly powerful. Now, there are a few ground rules, and they're actually super helpful. First off, every single key has to be unique. Makes sense, right? You can't have two different definitions for the same word in a dictionary. Second, and this is my favorite part, the map automatically keeps everything sorted by its key. You don't have to do a thing. And finally, you can mix and match data types however you want. Map a string to an integer, a character to a number, whatever your problem needs. All right, theory's great, but how do we actually use this thing in our code? Let's get practical and look at the essential tools in your new map toolkit. This is what you'll be doing 90% of the time. Using these square brackets is just so clean. If the key apple isn't in our map yet, this line of code creates it and gives it the value 5. And if apple is already there, it just updates the value to 5. It's one little operator that does two jobs. It's awesome. Now, you do have a choice to make when you're getting data out. You see, it's all about choosing the right tool for the job. If you just want to read a value, and you are absolutely positively sure that key exists, use .at. It's safer, it'll yell at you with an error if you're wrong. But if you want to either grab an existing value or create a new one if it's missing, those square brackets are your best friend. And of course, you get the usual housekeeping functions. You gotta know how to manage your data, right? You can ask how many items are in there with .size, check if it's empty, or just wipe the whole slate clean with .clear. These are your everyday essentials. Okay, so it's flexible, it's easy to use, but the real magic, the reason we love STD.map, is because it is ridiculously fast. So let's pull back the curtain for a second and see why it's so incredibly efficient. Now, you don't need to be an expert on red-black trees. Not at all. But just know that this complex-sounding thing, this is the secret sauce. This special tree structure is what's working tirelessly behind the scenes, keeping everything perfectly sorted and making lookups feel instantaneous. Now, to really get a feel for this, just imagine a map that is absurdly huge. I mean, let's say we have 4 times billion things in it. If this were a simple list, trying to find just one item would take, well, you'd be here forever. But with a map, to find any single item in that ocean of 4 billion elements, it takes at most 32 comparisons. Let that sink in for a second. 32. That's not a typo. It's almost unbelievable how efficient that is. This mind-blowing performance has a name in computer science: logarithmic complexity, or O of log n. All it really means is that as you dump more and more data into the map, the time it takes to find something grows incredibly slowly. It's what makes maps a powerhouse for huge, real-world data sets. So let's put this into practice. One of the absolute classic problems that maps just solve beautifully is counting how many times different items appear in a list. Counting frequencies. Here's our challenge. We have the word explainer, and we need a final count of each letter. How many E's, how many X's? This is a perfect job for a map. First things first, we just create our map. The key is going to be a char for the letter, and the value will be an int to hold the count. And right now, it's totally empty. Simple enough. Okay, we hit our first letter, E. We use that awesome square bracket syntax. Now, watch what happens. The map looks for the key E. It's not there, right? So it creates a new entry for E, sets its value to 0, and then our little plus plus immediately bumps it up to 1. Boom, our first entry is.
Next up is X. Same exact logic. The map sees X is brand new, so it creates an entry and sets its count to 1. And check this out. Remember how I said it auto-sorts? E comes before X in the alphabet, and the map has already put them in order for us. No extra work.
And now we hit that second E. This is the key moment. The map looks for the key E again, but this time it finds it. So instead of making a new entry, it just goes to the existing one and increments its value from 1 up to 2. That's the beautiful dual-purpose power of those brackets right there.
And after we go through the entire word, this is what we get. A perfect, clean breakdown of every unique character and its final count. And would you look at those keys? A, E, I, all perfectly sorted for us automatically. That's just fantastic. So I hope you see that this isn't just another data structure. This is a fundamental tool. It's a whole new way of thinking about how you organize and access your data. Honestly, it's like unlocking a programming superpower. Seriously, you're not stuck with just numbers anymore. You can build these logical connections between anything you want. Usernames to profiles, product IDs to inventory, words to definitions. The possibilities are just endless. So the only real question left is, what are you going to build with it?